So, yeah, if you look at different mental ability tests, so you give people verbal items like vocabulary, you give them math problems, you give them spatial reasoning problems, so all the different cognitive tasks that you can think of, you find that they all cluster together. Meaning, I'll just put it bluntly, all the mental ability tests are positively correlated. Meaning, if you do well on one, on average, you're more likely to do well on the others. And so you can represent it like this, where all of the different tests kind of go together into one thing. And the G factor is what you extract from that pattern of correlation. So to be higher in the G factor means you tend to do well on all of these tests. So the G factor is sometimes called general intelligence or general cognitive ability. But if you zoom in, some tests will be more strongly correlated than others. So verbal and vocabulary items correlate even more strongly, and the math items correlate more strongly. Those would be S factors. So there's only one G factor, but then there's lots of S factors.
And is it only, it's only for IQ tests, or can relate to anything else?
So the G factor and S factors are only about intelligence, IQ tests, but the statistical technique is called factor analysis. And that can be used on any data. So as we'll see after reading week, this has been applied to personality, for example. And there, the standard model has 5 factors. Yep.
Can you explain means analysis?
Yep, so an end in this concept is a goal. So some goal that you want to achieve. A means is a step along the path of getting to that goal. So if you're reasoning in terms of means ends analysis, you're thinking, okay, I want to get Indian food. Okay, I have to get my wallet, walk to the store, do all of those steps would be part, and that's a simple case. Those would all be means towards the end. Or aimed at getting the end.
What about conjunction fallacy? Conjunction.
Yep. So conjunction means combining two things or joining two things. So a phrase with the word "and" in the middle is a conjunction. So Bob is, a CEO and a father. Okay, that's a conjunction. It's saying he has two properties. The conjunction fallacy relates to that Linda example. So, or this is an example of the conjunction fallacy. So I describe to you someone named Linda, and I say that she is intelligent, politically active, a university student. So I describe Linda, and I say, is it more likely that she is a bank teller or a bank teller and a feminist? And most people, when they first see problems like this, say the second one. It's more likely she's the second one, but that cannot be true. It can't be true that she's more likely to be this than this. Because if she's a bank teller, let me say it the other way. If she's a bank teller and a feminist, well then this is also true. So this second one can't be more likely. By definition, it's less likely. But when people say, oh no, the second one's more likely, that's the conjunction fallacy. Yep.
What's linguistic determinism?
So there's different things you could mean by that. The term that's used in the book that is similar is linguistic relativity hypothesis. The idea is that the language you speak determines, to use the language of linguistic determinism, how you think. At least I assume it's being used synonymously with linguistic relativity. So the idea is that people who speak different languages think in fundamentally different ways. That's maybe too extreme. The modern version that is more widely accepted is that yes, the language you speak influences how you think. There's lots of cool little experiments consistent with that. The simplest ones to understand are how different languages carve up the visual or the color spectrum in different ways. And you can get these effects in the lab where if there's a linguistic barrier between two colors, speakers of the language with that barrier are quicker at distinguishing colors that fall across that dividing line. So for example, Russians don't have, this is an example that's always used, Russians don't have a word for blue. They have goluboy and sini, which are like light blue and dark blue, and they're quicker at distinguishing colors that fall on opposite sides of the boundary. There's lots of other examples like that that support a maybe mild version of the idea. Yep.
Hi, sir. Could you explain the sunk cost fallacy?
Yep. So I don't think I need to write it down, but sunk cost means investment you've already made in a particular strategy or course of action. And it's sunk because you can't get that investment back. You already put in the effort or spent the money. What people do is they try to do things that justify the investment they already made. I think the example I gave in class was, suppose you're in charge of a sports team and you buy an expensive player, but it turns out that he sucks. Like once you start playing, he sucks. But you keep putting him in the field anyways because you want to justify the fact that you spent all that money. But in strictly economic terms, that's irrational. You already spent the money. There's no point in using it.
Can you compare prototype theory and exemplar theory?
Good. So both of these are theories about how we use concepts. And in particular, it's helpful to think about how these theories work when we think about new cases. So you see an animal and you have to decide whether it's a dog or not. Both theories think about concepts as clusters. So there's clusters of things. So let's say dog. Or let's use bird. Bird is easier to make this point clear. So some birds are in the middle. And what I mean by that is they have the properties that most birds have. They fly, they have wings, they lay eggs, etc. Some birds that are towards the outside are kind of weird. They only have some of the properties that we normally think birds do, like penguins. Penguins don't fly. Yeah, they're birds, but they're kind of weird. So both prototype and exemplar theory think that when we see a new case, what we do is we compare this animal to something else in terms of how similar it is. Exemplar theory says we compare this to actual examples like in the middle. So if this new animal, we're trying to decide whether it's a bird, we think of robins, blue jays, and crows. And think, is this similar to robins, blue jays, and crows? Prototype theory says we don't compare it to like a set of birds. We compare it to a prototype, where a prototype is a kind of abstraction, kind of like an idealized bird, like a really birdy bird in our head. So they're similar theories, but that's the key distinction.
So with the prototype would be like focusing on the characteristics.
No, so like imagine that you have in your head like a bird prototype, where a bird prototype is like the most birdy bird you could it's not any specific bird, like a bird like a crow or a robin. It would be a bird that lays eggs, flies. I almost want to say like a heavenly bird. That's not quite what I mean, but it'd be like the perfect bird that had all the criteria that the features that most birds have. And when we look at a new bird, we compare it to that prototype in our head.
there's like a new case, do you have to use both the theories to figure out?
So these are different theories. There's arguments for each. I'm not an expert in it. You don't have to decide which theory is right. They're just different theories about how it works.
So I guess example would be like, if I'm looking at like a new dog, I would compare it to like a certain breed.
Like a few breeds, a few really typical breeds. So you probably wouldn't think of Chihuahuas or Poodles, because Chihuahuas and Poodles are kind of weird. You would think of like Golden Retrievers and I don't know, what are some other common, like some really typical dogs.
Ventromedial prefrontal cortex.
So I don't think I drew this in class, but it might be helpful to think about it like this. So this is obviously an oversimplification, but it's the way to think about it for the test. So there's the cortex, which is the outside part of the brain. There's the limbic system. So the limbic system includes like the amygdala and various other more like emotional parts of the brain. I don't think limbic system is in the key terms, but and in particular the frontal cortex is more involved in the human types of thinking, so like conscious, complex reasoning, thinking about the future, planning, self-control. The VMPFC would be like here. So it has a lot of connections with the limbic system. So the way you can think about this is, it's emotions influencing your decision making. Because the frontal lobe is what makes the decision, if you like. The ventromedial prefrontal cortex is where you feel that some outcomes would be bad. So what's been studied is, you can look at people playing like gambling games. Like there are different kinds of games you can play. Some pay off and some don't. Most people can stop doing a particular strategy before they consciously can articulate why. They just sort of feel like, whenever I do this, I keep losing money. I better stop doing that. People with this part of the brain damaged are less able to do that. They're less able to feel, if I do that again, I'm probably going to lose money. So I think the term using the key terms is anticipatory feeling. So the feeling that, okay, I'm anticipating that something bad's going to happen if I keep doing this. That's part of the job of the VMPFC.
So for people with the damage, that part of the cortex, does that mean they can like never stop gambling, for example? Or
They can. They're just less good at it compared to others. They will keep doing a bad strategy even after they should have been able to feel that, okay, this is not working for me.
Is this related to the Iowa-born gambling thing?
Oh, I think that, don't quote me, I think that's the one that's used. So it's Antonio Damasio is the one who summarized a lot of this work in a book called Descartes' Error. I forget if that's the one he used, but it sounds familiar. So you can Google that, I guess.
is two-factor theory same as factor analysis?
So don't worry about the term two-factor theory. Worry about the factors that are included. So factor analysis is the technique. So factor analysis is a technique that allows you to look at correlations between items. So, and you can look at how they cluster together. And the punchline from intelligence research is, if you give mental ability tests, so like verbal reasoning tests, math tests, spatial reasoning tests, all those kinds of things, you find that there's one cluster of questions. So these would be like test questions, and they all go together. And what I mean by all go together is they are all positively correlated. So people who do better on math problems, on average, also do better on verbal problems. and so on for the others. So that is what the G factor is about. The G factor is a factor you can extract to explain why some people do better on all or most of these, and why some people do not well on all or most of these. So that's the G factor. But if you zoom in, some of these questions are even more strongly correlated. So, you know, the math problems will probably go together, right? People who do better at math. So people who do better on math tests, yes, they tend to also do better on verbal and spatial and everything, but they're obviously especially more likely to do well in the other math problems. The math problems go together even more strongly. Things like that are S factors. And the reason for the letters is, you know, G factor means general intelligence, so the extent to which you tend to do well basically on everything. And S factors means specific abilities. Yep.
Is this Charles Spearman?
Yes, Charles Spearman, yeah.
And you also teach about like other models?
Other what?
Maybe not models, but like other people in history who thought different things. Like I don't remember.
Yeah. So there's other people who, I guess you could say, emphasize the S part more. So we talk about Sternberg and Gardner. You might be thinking of them. So they both had theories of multiple intelligences. Gardner, in particular, was very influential in education. There's debate about, you know, whether some of those abilities are best thought of as other intelligences, but yeah, there are other, you know, players that we talk about.
You said that the older you get, the more similar you will be to the
Sorry, hard to hear. Saying it?
You said that the older you get, the more similar you will be to the identical twin you've never met. And
Yes.
you gave us like two possibilities or explanations, and one of them was like, if you're older, it means like you have more control over your environment.
Yeah.
So that would be why. And what was like the second explanation?
That's the only explanation. I think the second thing I said was I gave another example of a gene-environment interaction. So the explanation for the fact that heritability goes up with age is what you said, that people have more control over their environment. But the other thing wasn't another explanation of that, it's another example of a gene-environment interaction. I can explain that too if you want, but it's kind of a separate thing. Yep.
What's the difference between crystallized intelligence and fluid intelligence?
Yeah, so crystallized is, the way to think it, you can imagine like your brain is like a warehouse full of facts, like full of stuff that you know, and you can think of it as like solid structure, so a bunch of solid structures you have. So crystallized intelligence is that, if you want to think about the crystal as a kind of metaphor. It's how much stuff you know. So vocabulary items, general knowledge items, those would be measures of crystallized intelligence. Fluid intelligence is how good your brain is at solving new problems. So it's more of a dynamic kind of intelligence. There's different spatial reasoning problems that I showed in class. Those would be examples of fluid intelligence measures. And for whatever it's worth, what I was about to say about aging was crystallized intelligence stays pretty stable after the mid-20s, maybe even goes up a little bit, but sadly, fluid intelligence starts going down in the mid-20s. So as far as how good your brain is at solving new problems, it peaks in the mid-20s. Yep.
Could you explain the neurodeficiency in the Q?
Yeah, so there's the older studies, I mean some studies still look at this, but what a lot of people assume matters about the brain vis-a-vis intelligence is just size. But size doesn't explain all that much of the variance in IQ scores. So another thing that's been looked at is neural efficiency, which is about how quickly and efficiently the brain processes incoming signals. So there are really simple measures of this. One thing you can do is hook people up to EEG, which measures electrical activity at the scalp, and measure how the brain responds to visual stimuli. And if your brain responds more quickly to it, that's positively correlated with higher IQ scores. Another one is how much glucose the brain uses when it's doing different tasks. If the brain can use less glucose to accomplish the same task, that's also associated with higher IQ.
So that would be about like the patterns and how the neurons are connected to each other. Right?
Yeah, exactly. Yeah.
So there's two equations we use for IQ tests. Like the first one is what's his name?
Ratio IQ. Yeah.
Yeah. So that one we don't use anymore.
Yeah.
And we use the newer version now.
Yeah.
Okay. Do we have to know like the exact equation?
You do for ratio IQ, not for deviation IQ. I used to teach it. If you look at my old Psych 105 lectures at the U of A, it's there, but I didn't test on it. It just seemed kind of mean. So you should know what both of them mean, but you only need to know the actual equation for ratio IQ.
So we use deviation IQ because it's better for like adults compared to how the other one is for children.
Yeah, exactly.
What are the stages of language development in children? Like the babbling stage?
Yeah, so I don't have like the exact months in front of me, but yeah, so babbling is first. They make, just like noises like mama, I mentioned in class, and the textbook actually gets this wrong. I double checked. Ma and ba are the easiest ones to make. You just push the lips together and push them apart. They start making other sounds. Then they start making words and enter the stage that's called telegraphic speech, which is like a few words at a time. So like, me want apple would be like telegraphic speech or something like that. And then they enter a period of rapid vocabulary growth. They start, learning words very quickly. And then the key thing after that is they start to learn grammatical rules. And the reason we know that what they're doing is learning rules is they start applying them to cases where they don't apply. So even though we don't hear, or babies don't hear adults say bringed or swimmed, right? Mom and dad say swam and brought. Kids will say swimmed because they've internalized the rule, add ed, and then start over applying them. Those are kind of the key early stages.
Is that like there's one and then there's two of them?
Yeah, exactly. So I know you're in 1100, so you wouldn't have seen it. But yeah, there's a video of it's Steven Pinker doing those kinds of studies where you teach the kid new nonsense words that they just made up, so they know the kids haven't heard them before, and the kids effortlessly add s or ed, when it's plural or past tense. Same kind of idea.
Can you explain heritability within group design? Why heritability between the groups?
Yeah, this is maybe the hardest concept in the chapter. It's one that a lot of students struggle with. So with heritability, we can look at any population, where there's variation. So let's say this is like the curve for IQ scores. We can get an estimate of how much of the variation is due to genes. So you do stuff like twin studies, right? You look at how much of the variation is due to genes. Okay, but then we discover that there's an average group difference. So the controversial section of the book is about the group differences in IQ scores. And it's tempting to think, well, if we know IQ is heritable, then the group differences must also be heritable. But that's a mistake. It's not a valid, like the group differences may or may not be heritable, but we don't know from things like twin studies that the group differences are heritable. And here's the example I gave in class. Forget about humans. Suppose I took a fistful of seeds that come from the same group of seeds, but I split them into two groups. One group I put in good soil, and one group I put in bad soil. So as you can see, the average height is higher in this group than in this group. Now, if I was to analyze the role of genes in influencing height, I would find that, why is this one taller than this one? Well, mostly genes, right? There are going to be genetic differences between the seeds. So height in grass, blades of grass, is very heritable. But that doesn't mean that the difference between this group and this group is heritable. In this case, we know it's not because of genes, it's because of the environment. Now, in the case of human ethnic groups, we don't have the same kind of good methods for getting at this. There are some studies I mentioned in class that point against the idea that those group differences are genetically caused. The only point with this is the fact that the trait in question, in this case IQ score, is heritable, which it is, IQ is heritable, that doesn't necessarily mean that the group differences are heritable. Does that make sense?
A little. So are you saying like it's also due to the heritability, but also the environment?
So what I'm saying is, here's what we know. We know that IQ scores are heritable. How heritable? Maybe 50 to 70%. So that's variation between individuals in IQ scores. We know there are group differences in IQ scores. So here, numbers don't matter. I'll just do a bullet point. So these two things we know. We can see them. What some people want to conclude is the group differences are heritable. Or forget heritable, just say, due to genes. Just make it simple. And this last thing, we don't know. And what some people think is, okay, we can jump from these two to this. But that jump is not valid. This conclusion doesn't follow. And here's another way of putting it. It could be, and in fact it very likely is true, that people in different ethnic groups have different environments. So say in the United States, African Americans live in more poverty, worse schools, etc. And it could be that differences like that are what depress their IQ scores on average. Yeah?
To connect to chapter 2, is this basically a confounding factor?
You could put it like that, yeah. So you could say it's like the fact that people in different ethnic groups have different environments is a kind of confounding variable that prevents you from jumping to the conclusion that it's genetic differences that cause the IQ differences.
What we just covered, is that heritability of IQ?
It's the point that heritability within groups, or you could just say heritability, does not imply that group differences are heritable. I'm trying to think if I'm pretty sure it's on the key term somewhere, but.
It is, yeah.
Okay, yeah, so that's what I was, sorry.
Within and between groups.
They're different.
What's the difference between them?
So within any defined population, so you can take any population you like, and you can do twin studies and stuff like that, and get an estimate of how much of the variation in that group is due to genes. So forget IQ, which is maybe harder to conceptualize. Think about height, really simple trait. So you could take everyone in Canada and rank them from shortest to tallest. And if you use different methods, you can get the number that around 90% of the differences between people are due to genes. Why is Bob taller than Jimmy, and why is Jimmy taller than John, etc. And we know, based on these methods, that IQ is heritable. It's influenced by genes. But then we have a group difference in IQ, so these average differences that we talked about. And some people jump from that to think, the group differences must also be heritable. And what the book says, and what any intro textbook will tell you, is that's not necessarily true. The fact that a trait is heritable doesn't imply that the group difference is heritable. And I mean, here's another case that's even more, this is also true. Think of the Flynn effect. The Flynn effect is a kind of group difference. It's a difference between, people born, later in the 20th century and people born earlier in the 20th century. So, people used to do worse on IQ tests than they do today. The curve is higher now. And we know that that difference is not genetic. It can't be. There's there's not time for genes to change. So, but if someone said, well, IQ is heritable, so this difference must also be heritable, that would be a mistake. Now, in the case of ethnic group differences, I'm not saying we know for sure that genes don't contribute to the difference. I'm just saying that the fact that IQ is heritable, which it is, doesn't show that the group differences are due to genes.
So heritability within groups is measuring the differences within a single group due to genetics.
Yes.
And then heritability between groups, you can't measure it because due to environmental factors.
Yeah, or at least you can't jump from the first one to the second one.
So that's the key difference between the two.
Yeah.
So the height difference, for within groups, the height difference is because of genetics.
Yes.
And then what would it be for between groups?
So we don't talk about between group differences in height. I mean, there are some of those, I guess, on average, but the difference of the book, the between group difference is that the book talks about is IQ differences on average. I guess I'm trying to say the same thing, like in a different way. The right thing to say there is we don't know what the cause is. There's some studies I mentioned that point against the idea that those group differences are genetically based. But the real truth is we don't have good, like within group variability, we have really nice methods like twin studies, adoption studies, that give us a pretty good sense of how heritable the traits are. We don't have comparably good studies for between group differences.
Can we say like nutrition, for example, height? If we,
Sorry?
for example, height, can we say an environmental factor could be nutrition, like that lemon?
Sure. Oh yeah,
that you have?
definitely. Yeah, no, like I said in class, if you starve your kid will be shorter.
Would eye color be a good example for this one? Because your eye color is basically due to genes, but if you're like comparing between groups, it wouldn't really make sense.
I'm not sure it's a good analogy just because I don't know that the environment, things like poverty or environmental variables would influence something like eye color. Maybe there's an analogy there,
But
but
like if I'm comparing like, for example, like these group of people versus these other group of people, I can't really say it's because how would I explain it?
yeah, I mean, you can try and think of it. I don't think it's a helpful analogy just because it's not the kind of thing that's really environmentally shaped. Like I mean, it's influenced both by genes and kind of by random factors. Like there's kind of different, someone can have particular genes that leave it open whether they'll have blue eyes or green eyes, and development can be a somewhat random procedure. But to my knowledge, I don't know that it's influenced much by things like, environmental deprivation. I could be wrong about that, but for that reason, it may not be the most helpful analogy.
There was one slide with the bell curve of like IQ in humans. I think you said we need to know like a certain number.
So know the numbers, except for the decimals at the end, like 0.1, but you should know that, for example, 68% of people are between 85 and 115, about 95% are between 70 and 130, and then a little over 2% above 130, and a little bit over 2% under 70.
Could you go over the
Oh,
genetic-
sorry.
No, it's okay.
So this voice of God, I couldn't, yeah, but go ahead.
the genetic differences between groups, you said they're small.
Yeah.
Can you go over that a little bit?
Yeah, so this is one reason. So we just finished talking about the possibility that genes contribute to the between group differences. This is a reason to doubt that, to think that it counts against the idea that group differences in something like IQ scores are genetically based. The idea is just that, so the way I broke it down in class is, humans are 99.9% genetically identical, any two humans on Earth. If you zoom into that 0.1%, only around 10 to 15% of it is group differences. This is just looking at counting up the DNA differences. What this means is most human genetic differences exist within every group. So as it's sometimes been put, if everyone on Earth died except for one area, around 85 to 90% of human genetic differences would still exist. So only a small amount of the differences are, as I say, group differences.
So 99.9 identical.
Yeah.
The 9% is just the differences.
Yeah, so this part is of the 0.1.
0.
So the 0.1, this sliver would be all genetic differences between people.
Okay.
Of that 0.1, only 10-ish% are group differences.
So there's only 0.5 differences in humans?
0.1.
0.1.
Yeah.
And the example you gave was if we go extinct and there's the 0.1 still on Earth, it would make up all the differences.
Or no, so what I mean by that is so if everyone except people who live in South Korea or whatever, or one area, everyone else died,
Okay.
all of this would still exist. So most of the 90%
Okay.
of genetic variation would still exist.
Okay.
Yeah, some people seem surprised by that at first, but the way to think about it, if you want to get the right intuitions, ethnic group differences are visually very easy to see. You can usually tell by looking at someone roughly where they're from, or their family's from. But things like skin color is only a few genes. It's not a very big part of it. That's the way to think about it.
So if only people in Canada survive, for example, then eventually after years, if you reproduce, it'll be the same people as the people before. Only Canada was the people country
Is-
with people alive.
It's not about people, it's about genetic variants. So think of DNA, right? There's all these letters, in the DNA code. And there's differences. Some, everyone has somewhat different DNA letters. What this means is most of the genetic variants would still exist. So reaction range, are you in the Tuesday or Thursday class? Or sorry, sorry, this is 1200, Monday. So I didn't use this in your class, but here's one example I used for the Thursday class. So let's say this is the hierarchy for musical ability. So all humans ranked from the worst of all time to the best of all time. So someone like me, my reaction range might have been something like this. So, I'm not very musically gifted. So, I didn't practice very much. If I had practiced more, maybe I could have been better. The reaction range is given by the gene. So it's these are the outcomes you could have, and then environmental influence will cause you to be somewhere on that range. So someone who's one of the best musicians of all time, their range might have been like this. Yeah, they got to here because they practiced a lot. Even if they didn't practice, they probably still would have been pretty good. And someone like me, I could have practiced my whole life. I was never going to be up here. You could also think about height, right? Your genes may give you a reaction range for height, right? So if you're malnourished, you're not going to be as tall as you could have been. But, I'll pick on myself. My parents could have fed me a lot. I was not going to be 6'2", right? there's sort of a range of outcomes that are possible.
So no matter how much like effort you put in to choose, that's like your limit.
Yeah, that would be the idea. Now it's kind of theoretical. We can't measure exactly what the reaction range is, but that's the way to think about it.
Could you give a quick summary of the history of IQ testing?
Yeah, so the big guns, the earliest, it wasn't called an IQ test yet, but like a mental ability test was made by Alfred Binet, who was a Frenchman. So he designed it to identify which French school children needed help. So in that case, it had kind of a benign use. As I talk about in class, it also has some bad history. So the eugenics movement made a lot of use of IQ tests. So including here in Canada, people were sterilized on the basis of low IQ tests. So that's preventing people from having kids. The early tests, because as I said, they were used for kids, used, someone else asked about this, ratio IQ. So it's the age at which you're scoring, so to speak, divided by your actual age, multiplied by 100. So like if your mental age is 15, so you're scoring as well as the average 15-year-old, 15 divided by, if your age is 10, divided by 10, so 1.5 multiplied by 100 is 150. In modern times, the most commonly used test is the WAIS, the WAIS, which uses deviation IQ, which is based on how many standard deviations from the mean you are. There's other figures, like one early figure, probably the first person to study intelligence, although he didn't make IQ tests, was Francis Galton, who was Darwin's cousin. He invented the correlation coefficient too, but he's a bit of an unsavory character because he's arguably the founder of the eugenics movement. So.
And what about Louis Turing?
Yeah, Turing's important too. He did a longitudinal study of kids who scored very well on IQ tests. I forget the kinds of things he found. I'd have to look at that study again, but that's like what he's famous for. He did other stuff too, but one of his famous contributions is longitudinal study of gifted kids.
Could you give us an example of expected utility and its definition?
Yeah. So expected utility is what we should be relying on if we're perfectly rational. So we in fact don't. We're not perfectly rational, but if we were perfectly rational, we'd rely on this. This is the output based on two things. The payoff, I think I might use utility but I'll just say payoff here. The payoff that you'd get if you win the game or whatever, multiplied by the probability of the payoff. And then the result is the expected utility. So a simple example, if I say, okay, I'm going to flip you're into a bet with me. If I flip a coin and it comes up heads, I'll give you $100. If it comes up tails, I give you nothing.
There's a 50% chance.
Exactly, 50. So the probability is 50% or 0.5, and the payoff is $100. So the expected utility is $50. So that's, and when we're making decisions about what to do, what strategies to use, we should be using this. If you built a robot and you wanted the robot to make as much money as possible, you'd program it with this. But humans don't always go with this. There are various ways in which we make decisions on an irrational basis.
And the probability can always change, right, depending on the situation.
Yeah, exactly. Depending on the kind of bet or the kind of thing, yeah, it can be different. It can be 1, it can be 0.75. Or, yeah.
So for this example, if it was 0.7, the expected utility would be 30?
No, it'd be $70.
70?
So it's multiplied by. So you can do it in your calculator if you, but it's it's not like subtraction. So it's 100 multiplied by 0.7. Chapter 9, I think.
Yeah.
Yes.
Yeah,
Yeah, chapter 9.
It would be so.
Yeah.
So on a, this would be a multiple choice question, right? You wouldn't want us to calculate an expected utility.
Yeah, if all questions are multiple choice, it's possible that there's a question where you have to do it, but it'll be a straightforward one. It won't be like a close call.
So the reason we're not perfectly rational, is that related to the fallacies you mentioned earlier?
Not off the top of my head that I can think of. I mean, I guess the conjunction fallacy is kind of related, but one example that the book uses is the certainty effect. If this number becomes 1, we kind of give it magic status. As soon as we're certain of a payoff, we give it more status. So, let's say there's 2 options. So one option is, you have a 50% chance of getting, let's say, $10,000, or you have a 100% chance of getting, let's say, $4,000. So the expected utility of this one is $5,000. And the expected utility of this one is $4,000. So this one is, hey, if you just come up to me at the end of class, I'll just give you $4,000. This one is, I'll flip a coin, and if it's heads, I give you $10,000. Strictly speaking, if we were a robot, we should pick this one because the expected utility is higher. But people are, to the extent they fall for the certainty effect, are more likely to pick the second one because as soon as this number is certain, we gravitate towards it.
What is the ventromedial cortex and the anticipatory feeling?
So the ventromedial prefrontal cortex is, the short version is, it's what allows us to feel that some courses of action are going to be more costly. So earlier before you came, I kind of drew how it works in the brain, but the simple version is people who have that part of the brain damaged, if they're doing a gambling task, they persist in doing irrational gambling strategies because they don't have that feeling of, ooh, if I do that, I'm going to lose money and that's going to suck.
And so is that where the feeling's located? The
I mean,
ventromedial cortex?
I could be semantically picky and say, I don't know if I'd want to say it's where the feelings are located, but if it helps you, you could think of it that way.
But they're the same thing, right?
What do you mean?
Like the ventromedial cortex and the anticipatory feeling.
Yeah, the ventromedial prefrontal cortex is what allows for anticipatory feeling. Yeah.
How do like bridge from the limbic system to the brainstem?
Yes. Yeah.
Isn't necessary conditions just the differences each group has?
No, so necessary condition is an old idea about how concepts work, and it's wrong. It seems right. It's very intuitively appealing, but it doesn't work. So if you define something in terms of necessary conditions, what that means is you're saying that in order to belong to this category, something must or needs to have these features. So here would be an example. I define a bird like this. A bird is something that must have wings, fly, and lay eggs. And, oh, that sounds nice. But then you think about it like, well, but there's penguins and ostriches. They don't fly. Okay. And some scientific concepts are defined like that, but in ordinary speech, with like ordinary words that we use, most of them are not defined in terms of a list of necessary conditions.
What's a functional fixedness? And can you give us an
Yeah, so
example?
functional fixedness is being too focused on the function of an object, or what an object is for. So the example in class, if you were there, was the like using the paint can as a pendulum that can help the rope to swing. So a paint can's function is to hold paint. That's what it's for. And if you're too focused on that, you're too used to thinking about a paint can as a paint holder, it prevents you from being creative and thinking, well, it could also be used as a pendulum to swing the rope. So it's an impediment to creative problem solving. Yep.
In terms of concept formation, what is discrimination?
Discrimination is just being able to tell two things apart. The concept of discrimination is used in different senses in psychology, depending on the area. For example, in conditioning, like classical or operant conditioning, it's being able to respond to one thing but not to another that's similar. So you can condition, a kid to be afraid of a white rat or whatever, as you may have seen that example. If the kid is only afraid of white rats but not white lizards, then he's able to discriminate, to tell the difference between them. So it's not like discrimination like racial discrimination. That's like a different sense of the term.
What's the difference between logical validity and syllogistic? I don't know if I'm saying that right.
Good. So logical validity is a property that you hope syllogistic arguments have. So a syllogistic argument might be like the one I used in class, all men are mortal, Socrates is a man, conclusion, Socrates is mortal. So that's a syllogistic argument. Logical validity means the premises guarantee that the conclusion is true. So I'll write that example out. So all men are mortal. Socrates is a man. Conclusion. So these first two are the premises. They are the statements that are supposed to support the conclusion. The conclusion is Socrates is mortal. So this has logical validity because if these two premises are true, they guarantee that the conclusion is true. As I said in class, if someone says, I believe this and I believe this, but I don't believe this, they're being irrational. They're contradicting themselves. So if that's true, the argument has logical validity. But as I also pointed out, logical validity is different from truth. You can have a logically valid argument with false premises. So, if I say, all men are made of cheese, and Socrates is a man, conclusion Socrates is made of cheese, that's still logically valid. The premises guarantee the truth of the conclusion. It's just that in this case, they're false premises.
Okay. And
Or one of them is false.
could you give an example of the syllogistic?
Yeah, like this. Yeah.
That's it?
Yeah. So this is a syllogistic argument that also has logical validity. So this is kind of simple, but if I said this, some men are mortal, this would still be a syllogistic argument. It would just not be a valid one. Because now the premises don't guarantee that the conclusion is true. Because if it just says some men are, now the conclusion is true, of course, but now with the structure, these two premises do not guarantee that the conclusion is true. So it's still a syllogistic argument, just not a valid one.
So basically 1 and 2 equal 3. And
Yes.
if
Or need to show that, or guarantee that 3 is true. Yeah.
and if 3 doesn't make sense, that means if the conclusion doesn't make sense based on the first two.
That's crucial, based on the first two, yeah.
So it has to make sense.
or I wouldn't even say makes sense, just that makes sense has to do with whether it's clear. It could be clear, but not follow from the two premises. So the two premises have to guarantee that the conclusion is true.
That's the logical validity.
Yes.
So like the two statements supports the conclusion.
Yes.
And what's the other one?
Truth. So truth is about, are the statements accurate or not? So I'll write one out. You know, here's like a silly one. If I say all rocks are pink, two, who's a real person? Donald Trump is a rock. Conclusion, Donald Trump is pink. This argument has logical validity, but the premises are not true. The premises are both false. But if the premises were true, they would guarantee that the conclusion is true.
So it's basically false versus the truth.
Well, truth is about, the truth is about whether the premises are accurate. So do these statements correspond to the way the world is? Or do they accurately describe reality? So, this one, Socrates is a man, that's true. Or I guess Socrates was a man. That's accurate. These two statements are both inaccurate, right? Not all rocks are pink. Donald Trump is a human being, not a rock. But the logical structure of the argument is valid.
So even if the two statements don't make sense, but the conclusion makes sense because of the two statements, is logical validity?
So one crucial thing, and this may be me being picky, but makes sense is about like whether it's clear. I would say these two things make sense. Like, I understand what these sentences mean, they're just false. They're just untrue. So even though the premises are untrue, they still would guarantee the truth of the conclusion. In other words, if these are so logical validity, one way of stating it is, if the premises are true, the conclusion has to be true. And this argument has that property. If you ever take a critical thinking or symbolic logic class, this will be like half the class is this kind of thing. In this class, we just get a brief treatment of it.
But the syllogistic, that one is, sorry, what's the difference between that one and the logical?
So all of these are syllogistic arguments, and then the question is, do they have these two things, logical validity and truth?
So opposite of logical validity would be the truth.
No, they're not opposites. They're two good things you want. So the best arguments will have both. If an argument has both logical validity and truth, that's like the ideal. It's like like this has both. Well, Socrates is dead, so it's a little weird to say it's true now because it's in the present tense. Whatever, I'll do me. So David, so all men are mortal, that's true. David is a man, true. David is mortal. Well, if these two are true, it guarantees that this last one is true. So this argument has both logical validity and the premises are true. That's like the best case scenario.
So even the second example, all rocks are pink one, it has logical validity, it's just the two
Yes, exactly. Yeah.
So I guess if you have to explain logical validity is if the two statements support the conclusion.
Yeah, that's one way of saying it. Yeah.
Could you give an example of illusion of explanatory depth and the other one that you were looking for?
So illusion of explanatory depth is just people think they understand things better than they do, so they think they understand how things work. And the easiest way to shatter that is just to get them to explain it. So if you ask people, do you understand how zippers work or toilets work, which is the example that I took from the book, or maybe from another book, whatever, I took it from some book. Most people say, yeah, I understand how that works. But if you ask them, well, please explain it, they'll then discover that they don't understand. So it's hence illusory. The illusory truth effect, I think is the other term you're talking about, is just that when statements are more familiar, like you've heard them more, you're more likely to believe they're true. So a lot of propaganda works on that basis. Yep.
Is that like the mere exposure effect?
It's similar. The mere exposure effect is about liking things. This one is about believing them to be true. So the mere exposure effect is the more you're exposed to something, the more you like it. This is the more you're exposed to it, the more you believe it to be true.
So would an example be like, if your mom tells you to that this thing is like true, should you believe it even if she's wrong?
Yeah, sure. Yeah, that's a good example. Yeah.
But does it always have to be like false, or could it be like fact?
That's a good question, actually. So yeah, I'm not sure what to say. Like, so suppose you believe something that happens to be true, but you believe it because you've heard it over and over again. I don't know if the definition includes that or not. I won't have a hard case like that on the test, is what I'll say.
What's confirmation bias? And could you give an example of that?
Yeah, so confirmation bias is reasoning in a way that tends to confirm the beliefs you already have, so it's confirmation. So it's reasoning in a way that is trying to prove yourself right. So you look for evidence that supports your belief, and you interpret evidence in a way that supports your belief.
And do we need to know the terms bottom up and top down?
Is that in the key terms?
Is it, but it's also in the study notes, so I wasn't sure.
So it's in the study notes, but not key terms?
Yeah.
I wouldn't worry about it. It probably was in the textbook from the course I used at the U of A. Yeah, no, I wouldn't worry about that. It will come up later in the course. Or actually, wait. No, it'll come up in 1100.
The G factor,
Mhm.
so it starts off with two-factor theory, and it goes down into two, so the G factor and the S factor, right?
Yeah, so I wouldn't worry about the term two-factor theory. It might be in the key terms, but I won't. I don't think I'll ask about that term. Focus on the idea that with what you find, if you give batteries of mental tests, so vocabulary tests, math tests, spatial reasoning tests, reaction time, like processing speed test, you find that they're all positively correlated, so they all go together. The G factor is what explains why all mental tests are positively correlated. So people who are higher in the G factor do well at everything. People who are lower in the G factor do worse at everything. But you can still zoom in and see that some tests correlate even more strongly with each other. So like the math tests will especially go strongly together, and the verbal reasoning or vocabulary things will go strongly together. So those would be the S factors, or specific abilities. So G factor means general intelligence or general cognitive ability, and S factor would be like verbal reasoning, math reasoning, or spatial reasoning.
So basically skills.
Yeah, more specific skills. Yeah. But it's still going to be about like mental, like reasoning type. It's not going to be like like musical intelligence or something from Gardner, it's going to be the kinds of things on IQ test. Yep.
Is there like, so is the G factor value of the G factor just like the average correlation on the test?
So it's more, what it is you can extract like a dimension or a factor on which the tests load. So it explains about 40 to 50% of the variation in tests. To speak more precisely, I should be a statistician, which I'm not. It's the first factor you'd get out of the pattern of correlations between tests is the best way I could say it. If you want like a really exact definition, you have to ask a statistician. One fun fact, whatever it's worth, is related is some IQ subtests have a stronger G loading, so they're more strongly correlated with the G factor. So like vocabulary, for example, is very strongly correlated with G. Other tests are less, so like the digit span, like how many numbers can you say back in a row, is like mediumly correlated with G. I think probably the best, or one of the best, is like the Raven's progressive matrices, which is like a spatial reasoning set of problems. Those are also quite highly G loaded, is the term.
So for the S factor, if you're like good at math problems, you won't be so good at like reading or like writing because you're only focused on one particular like task.
So here's the way of thinking about it. So on average, people who are better at math are better at verbal and spatial, etc. So G, if you had to like represent it, if you put all IQ tests together, they are all positively correlated. But if you zoom in, some are like more positively correlated with it. So like the math items especially go together, or the verbal items. But yes, obviously there's going to be some exceptions. So if someone is like really good at math but bad at everything else, like some people will be like that, then yeah, they have an especially high S factor for math. The general trend isn't like that, but yes, there obviously will be people like that.
So you said you don't want us to know the definition for two-factor theory?
I wouldn't focus on it. I mean, just to be safe, just in case, it's just the theory that intelligence is a product of both the G factor and S factors. That's all it is.
You mentioned in class something about regretta and arsenic. I don't know if I'm saying that.
Yeah, I won't test you on that specific example. It's just an example of how, so the term regatta means boat race, and it's the kind of term that probably only people who are part of, for lack of a better term, white upper class culture would know. So the objection is this isn't measuring intelligence, it's measuring exposure to kind of upper class culture. So it's the kind of item that people would object to on that basis.
And the other one?
What other one?
The arsenic?
Yeah, so it's so the question that I think it comes from the SAT, not an IQ test, but it's this. You can object to some items on older IQ tests in the same way. The question is like a runner is to a marathon, as a blank is to a blank, and then it's multiple choice. And the right answer is oarsman to regatta.
Mm-hmm.
So. Okay, well we're over time, and I have places to be, but if you have other questions, you're free to ask them on course questions. Good luck on the test.